I've been working in wood construction for a long time. Panelization is kind of the new thing, and double walls are a big part of a lot of the passive design. So I'm going to go through some details that we've dealt with in the double wall. Some of it's just a double wall assembly, but how does that impact your structure when you have prefabrication? So there's a lot of ways that you can do prefabrication. That's just me, you heard all that. The first thing, I'm going to be talking about Part 9 structures, and most of the residential passive house stuff will fall under Part 9, so this is your, make sure it's Part 9 list, because that's an important list to follow. So most things that are residential small buildings will fall under that, but every now and then you'll find things that won't. Sometimes it's a building code issue. Sometimes somebody at the province will tell you it's a care home and it's not a house, so you have to put it under Part 4, but these are the basic things that determine whether it's not or not it's Part 4. The reason behind that distinction is if you can do everything under Part 9, you don't need me. Go ahead and build. Just go to the building code, pull out your tables. They'll tell you how to nail everything. You don't need an engineer so long as you stay in Part 9. Most of the buildings today end up as a hybrid. There's some stuff that falls outside of Part 9. There's some stuff that can be done under Part 9. Some designers want nothing to do with the design aspect from a structural perspective. So even though a lot of it could be Part 9, they're happy to just say, you do everything. But this is what you could do without me. So if you stick under that, then you don't need engineering. But as I say, most things fall in between somewhere. So say you're going to do a double wall system and you're going to involve some panelized wall systems. There's a lot of different ways to do panels. So how will you build it? Will it be basically your stud wall, like stick framed, but showing up on site already built? Do you want to insulate it ahead of time? Who needs to see what? So if it's insulated, what are you hiding with the insulation? Storage requirements on site. If you're bringing all these panels to site, how quickly can you get them put up? Do you have any special storage requirements? How will it go together on site? And that's some of the details that I'm going to try and kind of quickly go through. But putting together something stick framed is not the same as putting together panels on site. So decisions and details. We've done several of these projects, and with each one we tweak the details a little because you get feedback from the site or you get feedback from the plant, and there's things that work and there's things that don't work. So with every project you learn something and you adjust your details. My least favorite part of panelization is the shop drawings. I thought truss shop drawings were bad. Wall panel shop drawings are very bad. You're trying to, especially on a larger building, you're trying to follow this little plan and figure out which wall I'm looking at. I can walk through a building on site and say, yeah, that's wrong, yeah, that's wrong, yeah, that's wrong. It takes a lot longer to look at it on paper and say, okay, this is that wall, this is that wall. Okay, wait, no, you missed a jack stud there. Oh, you missed a king stud there. So keep in mind that if you're panelizing, that adds to your construction admin time. So somebody's going to have to review those shop drawings. Are you getting your panels from a certified plant or an uncertified plant? If it's just stick framing and everything is visible on site, you don't need a certified plant. It's just like somebody has built it. The building inspector can walk through, see all the framing. Nobody really cares if it was panelized or not. If you want to bring an insulated panel to the site, it has to be from a certified plant because you can't see what's happening inside it. If you've covered it with wrap or covered it with foam and the building inspector can't see, you have to get it from a certified plant. And if you don't, then you're ripping open panels on site to check it. Been there, done that. So insulation details, how are you going to manage that from a panel perspective? Your air sealing and your insulation can be a little bit different when you're getting wall panels. Your structural details, your headers and jacks, mostly they're the same, but again, are they being done at the plant? Are they in the outside wall? Are they in the inside wall? Can you still see them on site? Does somebody have to certify that before it gets to the site? So some details have to be worked out. This is the certification you need if you want to get enclosed panels. So CSA A277, that's the certification. If you're just getting stick frame panels and you can see everything on site, you don't need to be certified. This is the same sort of standard that modular and prefab is required. So what this means is the assembly of these panels on site comes from a certified facility, and they can show up on site with the structure hidden, with whatever's inside of the wall hidden, and they will be accepted. Your building inspector will be like, okay, you have the certification, very good, I don't have to see this. Without that certification, the building inspector either wants to see everything, or they want an engineer that'll sign off and say that everything is as it should be. Some of the primary considerations with your connections. So really, we're looking at a couple. This is where it gets a little bit technical. Your gravity load and your uplift, we really want to follow our load path. So if you're bringing in panels, the way they're connected to the structure is a little bit different than if you're stick framing them. Our roof trusses, how are they connecting to the exterior walls? Connections at intermediate floors. Structurally, we have ways to deal with this. You were talking about reverse lap seams. That's an issue. If you bring something to site that's already wrapped and it's a two-story structure, you get that lap joint that you have to tape. How do you deal with that on site? Structurally, we have to deal with that as well. How are you connecting it to the foundation? If your wall already comes with a sill plate, how do you anchor that to your concrete foundation? If it's just stick framing, you can probably hilty it down, no problem. But if you already have it wrapped and covered in foam and a wrap on the outside, you've got to have another way to fasten that bottom of that wall to your foundation. Connections for your lateral load, again, if you're attaching it, you want to make sure that not only can the gravity loads, they're a little bit easier, they're just sitting on things, but can you take your lateral loads? How do you connect at the floors? How do you connect the foundation? How do you connect your interior wall to your exterior wall? That's a question with double wall assemblies in general, but some of it gets a little bit complicated in panelized construction if you don't see the structure underneath, if it comes in an assembled structure that is hidden by foam. These are some basic, so again, you don't need me if you're building out a Part 9. You can go and how do you fasten your bottom plate to the floor joists? You need nails that are at least 82 millimeters long, and you need to space them 400 millimeters on center. All of this is right in Part 9 of the code. Anybody can go and read it, free to anybody the last few years. Anywhere that the 1 in 50 hourly wind pressure is equal to or greater than 0.4, you need to use hurricane clips. Does anybody know if anywhere in Nova Scotia has wind that's greater than 0.8 kPa? There isn't. The highest wind load in Nova Scotia is Port Hawkesbury, and that's 0.74 kPa. So nowhere in Nova Scotia in a Part 9 building do you technically require hurricane clips. If you fall under the span limits, you can use toenailing. 3 toenails. That's all you need according to the building code.
So it's a money grab then.
Well, it's way easier for a building inspector to see that you've put in a hurricane clip than to climb up and check that you've put 3 toenails into every truss. Same as joist hangers. Lots of times you could end nail and get the proper connection, but how can you verify that it's done? It's easier for them to see that it's done if you put in a joist hanger. Easier to see that your truss is properly fastened if you've got a hurricane clip. But by code in Nova Scotia, none of the locations are high enough that require that. Nailing of framing, again, all in the building code. It tells you how to attach your bottom plate. It tells you how, if you want to connect from floor to floor with your sheathing, how you can do that. How you can tie it down with metal straps as well. All of this fastening detail, if you fall within the span limits of the building code, you can pull this all out of the code without any extra engineering. This is a typical detail in Part 9. So probably one of my biggest issues with Part 9 of the code is that they only require sill plate anchors every 8 feet on center. If you're building walls in 8-foot sections, 1 sill plate anchor is not enough. So we would never specify detail with that spacing, but that is technically the code. 2.4 meters is 8 feet for those of you that don't do the metric imperial thing a lot, or 7'10", I guess technically. But that's a pretty basic detail. Now, if you're doing something that's modular, you're going to want your sill plate, but then you need to find a way to fasten it. This is, again, the minimum in the code, 1/2 inch diameter, 4 inches into the concrete, 8 feet on center. So we're going to start at the roof and work our way down. These are just some options for different details for some double wall assemblies. So in this top detail here, this is a case where a panelized wall has come to site and it's got foam on the inside. So I can't fasten into my top plate of my wall. The foam is in the way. So one option is to fasten from the outside. So you've got a hurricane clip on the outside, but everything has to line up properly. Anybody that's built trusses, your top plate and your end of your truss don't always match up perfectly. So that's a little bit trickier. And in that case, one option is to add the plate on site because there's already a plate on the wall. So you're adding a double plate on site. Again, you're attaching your inside wall to your outside wall. That even though the inside wall is not structural, when you design for wind load, you have pressure on the outside, but you also have suction on the inside. So you need to make sure that some way or another, your inside wall is attached to your outside wall. So you can attach it with some longer screws. One of the things today, there's a lot of longer screws available. So some of these connection details are made possible by some of the fasteners that we can get today. So you can get a long structural screw to go from through a 2x4 wall into a 2x6 wall through the foam. So that's always an option. And that detail over there, this is a detail where they've got 2x4 strapping, which is structural enough that you could fasten your non-load bearing partition so that it's connected for wind load. In that case, you would have a wall that didn't come with foam on it, so you can do your pretty typical detail, hurricane clip to your top plate. Nothing too special, but if your foam was on ahead of time, you can't make that connection detail unless you put the plate on after the fact. If you do that, you then have to make sure you have fasteners to connect the two plates together. So some of this is not typical in the building code. So when you get some of these custom details, that's where you need somebody to do the numbers on the fastening and make sure that it takes the load that you need. You can always use your sheathing to connect one wall to another. So in this case, a second plate is added on site and you put sheathing on the end of your truss and fasten it with just basic nails into your additional top plate. So that's a pretty straightforward detail. You can toe screw or toenail, similar to what the code is. So this is a really easy one. Your panelized wall comes to site with your double top plate. You've got your foam on it. You're fastening through from your interior non-load bearing partition. And so long as you can get up and at that angle, depending on your truss geometry, you can toenail or toe screw that in. And that's a pretty basic, straightforward detail. Don't have a lot of details for floors, but basically if you're bringing panels to site, you're not going to get that sheathing overlap that you often get in stick-built construction on site. One of the things at Part 9 is you're allowed to use these prescriptive methods that nobody has done the detailed calculations on because we've been doing it like this way for decades. So when you start changing the way you're building things, the prescriptive methods of the code don't really apply anymore. So you have to make sure that you're meeting the intent of providing that stability and structure to the building when you start going outside of the way it's been done for decades. So here in a stick-built construction on site, you would likely lap your sheathing to connect your floor, your wall above to your wall below. So if you're not doing that with panelized walls, because they've already come to site sheathed, you could put a metal strap on the outside. The strapping fastening is actually in the code if you need it. Or if you're doing it and the foam is not in place, once you bring your open stud wall to site, you can fasten with a screw down to the plate. Screws are better in pull-out withdrawal resistance than a nail. A nail can be used for withdrawal load only for temporary wind loads. So if you're looking at uplift on a structure, you need to make sure that you're fastening it properly. So that would be a special connection of connecting two walls together if you're not having the lap of the sheathing or the strap that's in the building code. So you might need somebody to work that out for you. These are some details at the foundation. So you can see they all have a double plate at the bottom, one plate that gets fastened to the concrete during construction, and a second plate that comes on the bottom of the wall. So you can screw through the outside and fasten them down that way. If they are open, you can fasten them down through the top of the plate of your panelized wall. You can have your panelized wall come to site top right corner with an overlap of the sheathing. So you run your sheathing 1.5 inches long on your panel, tilt it into place, and just nail it into your sill plate that's fastened to the concrete. That's a very simple, affordable way. So again, they're not overly complicated, but somebody has to think about them before you say, oh, we're going to go panelized, and not realize the implications of all the extra details that you have to work out. And all of these fasteners, although great and generally readily available, are expensive. So if you say, oh, we're going to save all this money and time and labor by panelizing, but you have to spend $1,000 on fasteners to make it all work, you're offset. You've got to think about how that affects your bottom line. Basements and corners, we haven't really done, most of the ones we've done so far with panelization have been slab on grade. So I came up with a proposed detail of how you might do it with a basement. Again, you just need to make sure you've got your load path covered. In this case, I didn't draw it in, but your floor would be, that might be ICF, and you'd have an ICF hanger. So your floor is attached to your foundation, your wall's attached to your foundation, your interior load-bearing wall gets attached to your rim board. When you do a double wall, and if you're panelized, you can actually save yourself a bit of insulation space and leave a gap on the inside corners. So somebody could stuff some insulation in that corner, your drywall can overlap. So you can actually get better corners in the double wall assembly because you're not trying to add stacks of studs to a corner to get the sheathing on the outside and the drywall on the inside. But again, you need to make sure those two walls are connected. So around windows, you want to make sure your jambs connect the two walls. At doors, sometimes there's a problem if you're doing a 2x6 outside wall and a 2x4 inside wall. If you buy a door assembly that fits to the 2x6 wall, it doesn't give you any space to make that connection between the two walls. So you need to add a cleat on the inside, connect them. Or if nobody did it during construction and all of a sudden your wall is moving, you can drive some of those long screws like some of the other details we showed before, attach your inside wall to your outside wall. So those long screws can come in handy for fixing issues when you have a double wall assembly, whether it's related to panelization or not. Maybe you can't see where you need to tie the studs together, but around the edges, you know that you've got your plates at the top, your plates at the bottom, so you know some places that you can make that connection. So final thoughts, plan. Like you really do have to think through all these details. You can't just at the last minute decide to go panelized. You need to know what you're doing, what type of panels you're getting, what's going to be done on site. If they're stored too long on site and they're wrapped panels with insulation, what if they get wet? How do they have to be stored? How are you going to put them up? Does your site have good access for a crane if you're craning them into position? Plan. It's really in the details. That's where you're going to be successful. And a team approach really is important. The detail that I think is best structurally might not be the best detail for insulation or air sealing. It might not be the most cost-effective detail. It might not be the easiest to build. It might not be the most time efficient. And it might not be most suitable for weather conditions. Panelization is great when you don't have good weather, maybe workforce ability, but it's not going to be the right solution for every job. Panelization is big now, but it's not new. The first panelization job I worked on was probably 15 years ago, and it was a workforce issue. They couldn't get the trades to the location of the job, so they panelized it 4 hours away and shipped the panels. So it's a solution, but it shouldn't be the only solution. You shouldn't just grab it because it's kind of the trendy thing to do. Make sure it's the right solution for your job. Thank you.